classes. We have completed thermistor, thermocouple in module 4. We will discuss the next topic is a thermistor. Subject name is a sensor and transducers. Module is a 4. So first we will discuss about the what is the thermistor. Thermistor is a devices which change the temperature, which detect the temperature and its resistance changes according to its. For example, this is the thermistor. This is the thermistor. Thermistor. Input is a temperatures, then its resistance is changed. Output is a change in resistance. This is the thermistor. So thermistor is a temperature sensor constructed for semiconductor material that exists a large modification in resistance in proportional to any tiny low modification in temperatures. Means this is the thermistors. Its input is a temperatures, output a resistance. This is the function of it's take the input and temperature and outputs resistance. The type of thermistors we will discuss the type of thermistor. Well, NTC thermistor. NTC thermistor negative temperature coefficient. NTC is negative temperature coefficient. In NTC or negative temperature coefficient thermistor is a devices whose resistance is decreases with increase in temperatures. These type of resistors are usually exist a large, precise and predictable decrease in resistance with increase in temperatures. Means if we increase the temperatures, then its resistance will decrease. NTC, this look like this. NTC look like this. You see this graph, it graph look like this. Here temperature is here and here change in resistance is here. NTC change in resistance and here. So this is the NTC. This it we increase the temperatures, its resistance decreased the exponentially. This is the NTC. This material used for construction NTC like unlike resistor, the fixed or variable. These are ceramic or polyester. Material name of the material second is a ceramic and polyester which are composed on a metal oxide that are dried and sintered into obtain the desired factor. In case of NTC thermistor, the cobalt, nickel, iron, and copper oxide are preferred. So this is the symbol of NTC. This is the symbol of NTC. How we can represent this? We can use this symbol for NTC resistor. Second, characteristics curve. So this is the characteristics curve of negative temperature resistance. We have already discussed thermistor that used at absolute zero temperature. Absolute zero means minus 270 degree Kelvin. Absolute zero means minus 270 minus 273 Kelvin. Minus 273 Kelvin. 73 Kelvin minus 273 Kelvin. This is absolute temperature. This is the graph shown here. This is the 1 minus 100 degree Celsius. Its resistance approximated in the range of mega ohm. This is the range of 10 mega ohm. Its temperature increases, its resistance start to decreases. At 25 degrees Celsius, its resistance is a 200 252 ohm at the 25 degree Celsius. Thermistor characteristics. Some characteristics we can suggest the heat dissipation. Like any resistors, thermistors also dissipate the heat when its significant amount of current pass through it. This heat is dissipated in the core of thermistor. Therefore, the temperature of precision of the devices. That means what is the heat dissipation? Means this is the any thermistor in the resistive devices. So this is the resistive devices like this. Resistance is varies. If the current I is flow on this, current I is flow on this, then dissipation power P equal to I square R. I a current I square I square R. This is the means I is the current flow through the thermistor. So then I square into R is a heat dissipation on this thermistors. So this is the heat dissipation in thermistor. Second, heat capacity. The heat required to increase the temperature by 1 degree in negative temperature coefficient of thermistors is called it heat dissipation. Heat capacity means we want to increase the temperature to 1 degree Celsius in NTPC. That amount of heat is required is called it heat capacity. It, it defines the response speed of NTC thermistor and hence its knowledge is needed to the decide where it says to be used. Second is a PTC. We will discuss about the PTC. This is an NTC. This is the PTC. This is the graph of positive temperature coefficient is a PC. When we increase the temperature, its resistance is increases. So such type of devices are regarded positive temperature coefficient of resistance. Is that positive compressor type? That it is a two types. First, the first name is called as Celestor, and second name is called it other is a switching type of PTC. Switching type of PTC. So we will discuss this in detail later as we can discuss this curve. So Celestor versus PTC. So we see that PTC has a non-linear characteristic positive temperature. This means PTC thermistor is quite sensitive to the change in temperature, but quite its resistance increases linearly with increase in temperatures. The switching type PTC, however, is a different due to its polycrystalline ceramic body. It has a non-linear characteristics curve. So we see from the figure that up to certain temperature, let's call it is a threshold temperature. Resistance decreases with increase in temperature, much like NTC. So its temperature increases beyond the threshold temperature, so the resistance start to increases dramatically with increase in temperatures. So, so this is a thermistor. This is 825 degrees Celsius. Is the critical in a celestial type temperature increases slightly resistance decreases a certain point. It is the critical point. At critical point, TC is a critical point. Critical point. At critical point, it's move like this. Switching type PTCA. At critical point, it is the switching type PCA. And celestial is a resistance increases slowly. Let's it should be temperature. The resistance decreases with increased temperatures. It's much like NTC thermistor. As temperature increases beyond the threshold point, so the resistance start to increasing dramatically. This is the so, behavior of VTC. This is the we are discussing the above graph which has been seen. The switching type PTC, however, is a different due to its polycrystalline ceramic body because material uses a polycrystalline ceramic body. That's why it has a non-linear characteristics because after the critical point, its resistance start to sudden increasing a certain point. Let that point is called the threshold temperature. Its resistance decreases with increased temperature is much like NTC. Its temperature increases beyond the threshold temperatures. It start resistance start to dramatically. So sometimes this is this initially this temperature start to decreasing like this. It when it reaches the critical point, it start to sudden decreasing. That's why polycrystalline material. That's why this behavior is shown here. Look like as temperature increases beyond the resistance of the thermistor. The resistance of PTC thermistor are rated temperature at 25 degree. It means if we find the PCT thermistor that has rating low ohm, it's symbolized that its value is 25 degree at 25 degree Celsius. 200 ohm, its PTC resistance at 200 ohm and 25 degrees. Now we have to discuss this type of thermistor according to temperature coefficient is another classification of shape and size of thermistors. Classification based on the size and shape. Thermistor, whether it is a negative or temperature thermistor has a body made by metallic oxide. Its body made by metallic oxide. This, that means the body of the thermistor can be pressed into different shapes. They can be either pressed into bed discs or cylindrical shape. Therefore, one expressed into weights are known as weights. The thermistor, those those pressed into a disc that is known as disc thermistor, and similarly, the third class is cylindrical thermistor. Bead thermistor are the smallest in size of load. Thermistor working. How does thermistor work? Thermistor work on the principle of change in temperature of a thermistor lead to change in resistance. How does the temperature changes? Thermistor temperature can change either due to external factor or due to internal factor. Most of most important internal factor its current flowing through the devices is current through its increases it starts to self heating and its element, so this cause to rise temperature of the thermistors. So depending on the type of thermistor, either NTC or PTC, its resistance change with respect to change in temperatures. External thermistor temperature can be changed by changing the ambient temperature. The resistance and temperature relationship can be approximated following equations. This is the resistance temperature equations. R बराबर R0 into e to the power beta into 1 by T0. This name is RT. This name is this resistance name is RT. Resistance is T degree temperatures alpha into beta 1 upon T into T0. This is the resistance temperature detector. Resistance temperature relationship equations. R is a temperature at T, resistance of the thermistor is the T degree temp T degree temperature in Kelvin. R0 resistance is given temperature T0 in Kelvin. Beta is a material specific constant. In terms of temperature coefficient of resistance, this equation can be defined as R बराबर R0. This is the generally this is equation defined in terms of RTD. This is the equation is RTD, alpha into RTD. This is the RTD. So we will discuss about some basic thermistor circuit in application sections. Each thermistor that is NTC and PTC thermistor used in different applications according to needs. Negative thermistor applications. NTC, the most common usage of thermistors is that to measure the ambient temperatures. NTC thermistor being highly sensitive to temperatures consideration ideal applications. They are cheap, mostly used for temperature range minus 40 to 300. NTC generally used minus 40 to 300, minus 40 to 300. Minus 40 to 300. Apart from the temperature ranges can be either that is known according to while choosing thermistor for application including resistance ranges, accuracy surrounding mediums. The time depends. A very basic circuit that uses thermistor for temperature measurement is shown below. This one thermistor can be shifted into Wheatstone bridge, and we can find the balance and output according to this. So it's the application of thermistor. It can be seen like this applications. Temperature compensation. Even though all the semiconductor possess temperature coefficient of NTC has highly sensitive towards the temperatures, hence NTC opted for compensating understanding response to temperature changing in a circuit. The compensation network mostly comprises the resistor in series, shunt and voltage divider circuits, screw type thermistors. Application is temperature of the thermistor and component is responsive to the temperature change and should be matched. Common compensation. This is a temperature compensation network using thermistor. Here we can compensate the temperature according to this. Here thermistor we can use thermistor here and here. Generally, we will see this diagram for where the thermistor can application for temperature compensation thermistor can application. A fire alarm system and TPC can be used to build up fire alarm system basic circuit. This is the fire alarm system. Thermistor can use here like this. This is a fire alarm system. It's not. This is the only purpose for second is to monitor the temperature, maintain room temperature, a certain desired level, a stabilizer, laser diode, for so many ways. PTC application, all these applications are anti. Right now, PTC thermistor can be actually broadly classified into two categories based on the application. Let's discuss some applications. These power PTC thermistor. Power PTC the fuse for circuit that required over current protection. PTC thermistor act as a fuse. The ceramic PTC thermistor are replacement to the conventional fuse to protect the lead edge motor from shown figure using the PTC temperature and connected with series and load. This is the fuse. The PTC can be used for like a fuse application. The PTC thermistor can be used as a switch to monitor start circuit, degaussing circuit. Due to their resistance and temperature characteristics, PTC thermistors are good choices for small thermistors. PTC thermistor sensors. A PTC thermistor sensor used in various applications is level sensor. They are good choices to detect and control the oil and tax. Another type of sensor that is made using the PTC thermistors का, of course, of the temperature sensor. Here, these PTC use their step region. So many for protection for semiconductor devices. PTC can be used. Mm, so, this is the thermocouples. Already we have discussed the thermocouple previous classes. First, thermocouples are eff- mainly depend on the three effects, namely Seebeck effect, filter effect, and Thomson effect. Seebeck's effect is nothing. This type of effect, this this type of effects occur among the two dissimilar metals wh- when the heat offers to any one metal wire, when flow of current supply from the hot metal wire to cold metal. Therefore, this direct current simulated current. That means this is the two metal are joined together. He's saying like this metal one and metal two of semiconductor are joined together. This type of occurring two dissimilar metal A, metal B, metal B, when two dissimilar metal, when heat offer to any one of a metal wire, then flow of electron supply from the, this is the hot A, this is the hot junction A. Electron move like this. This is the electron direction. This is the electron. Electron should be moved from hot metal wire to cold metal wire. Therefore, the current simultaneous circuit. That's why current is flow, because electron flow from hot from here to here. So this is the called it Seebeck effect. When two dissimilar metal are joined together to make junctions, so the current form. So the electron flow from hot metal wire to cold metal wire. That's a Seebeck effect. Second is filter effect. This effect, the response to the Seebeck effect, that means stated the response of Seebeck. That means stated that the difference in temperature can be formed among two dissimilar metal, applying the potential differences. That means he's telling it this, if this same circuit, this two dissimilar metal are joined together, metal A, this is the metal A, this is the metal B, joined together, this is the B, this is the A, joined together, the two dissimilar metal are joined together, and he's can the temperature difference exists between them. He's telling that effect that the difference in temperature, this is junction one and junction different temperature, this junctions among any two dissimilar metal conductor, applying a potential variation to, that's why it create the potential differences. Means that's why we can write, we are writing that that potential difference V equal to S into this is a sensitivity factor into delta T, change in temperature. That's why is this temperature is just, then it create the voltages. This is called it filter effect or a Thomson effect. Thomson effect. This effect states that two disparate metal fixed it together to form a junctions. That voltage induced the conductor lengths due to the gradient temperatures. This physical words demonstrate the change in the rate direction to temperature. That means the statement means this is a thermocouple. This like this. This is the thermocouple. When this is the temperature T1, this is the temperature T2. Okay, this is the temperature. It's a, it is if the two dissimilar metal A, metal B are joined together, they form a junction. They form, then the voltage induced because of temperature gradient means here temperature gradient different, here temperature different, for high to low temperature is decreased. That's the induced voltage is induced that because of temperature gradients. This is said by the Thomson effect. Construction, grounded type, ungrounded type. We have to study all in detail. Then exposed, grounded type, working principle of thermistor. We have discussed in last class previously. And this is the electromagnetic force induced circuit. Either E theta, theta is temperature, B into theta square. Advantage, disadvantage. In this is important. Generally, this will ask about the differentiate between the thermistor, RTD, and thermocouple. So first we will discuss the difference in first temperature ranges. So generally the thermistors, the temperature range is minus 260 to 850. This is the generally temperature differences, temperature ranges. Thermistor minus 260 to 850 degrees Celsius. Thermocouples range minus 270 to 1800 degrees Celsius. High temperature range. Thermistor temperature is low, minus 80 degrees Celsius to 150 degrees Celsius. This is the thermistor temperature range. Sensor की cost, RTD cost moderate, so thermocouple cost is low and thermistor cost is low. But in case of RTD, the system cost is moderate, but thermocouple total cost is high because this is active. This is the no, there is no need to operate the power. That's why its system cost thermocouple is very high. दूसरा thermistor cost is moderate because its output is low, without any input it creating the output. That's why its system cost and maintenance is very high. Just stability, RTG the best stable because platinum resistance used is very linear and stable up to long time stability in RTD. Best stability. Thermocouple stability is very low. Thermistor stability moderate. Sensitivity, moderate sensitivity in case of RTD, but thermocouple are low sensitive. Very sensitivity is very low, and thermistor are moderate sensitivity. Yeah. Even thermistor are very sensitive. Linearity, RTG the best linear because we have used the platinum thermistors. Thermocouple linearity is a more moderate, different type of just K type generally more linear and gets the good output. Thermistor is a poor linear. It is a completely non-linear devices, and this is the specific for the general purpose sensings. High accuracy, average temperature ranging for RTD. Thermocouple highest temperature ranges है. In case of thermistor, based sensitivity, narrow temperature ranges, and point sensing. So this is the class for thermistor. In next class we will discuss about the thermistor and thermo.